NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
Nearly 24 billion kilometers from Earth, an ancient spacecraft broke its silence.
4.5 decades old and has been operating for nearly 3.5 decades, longer than it should have.
The signal wasn't data. It wasn't noise. It was something else. Fragmented, defiant, impossible. Voyager had crossed into a region no one understood, and what it found rewrote everything we thought we knew. The spacecraft that wasn't meant to survive. In 1977, 2 spacecraft launched from Cape Canaveral on what was supposed to be a 5-year mission. They were called Voyager 1 and Voyager 2, identical twins in hardware, yet destined for different paths through the solar system. Built with less computing power than a modern calculator and no plan for long-term survival, they were designed to photograph the gas giants, beam back a few snapshots, and fade into silence. Voyager 1 launched second, but overtook its sibling thanks to a faster trajectory. It rode a rare planetary alignment, an orbital slingshot that happens just once every 176 years. This gravitational chain reaction flung it past Jupiter and Saturn at unimaginable speeds, far beyond what it was engineered to endure. There were no backup CPUs, no AI, no solar panels. Its only power source, a nuclear battery that would slowly decay over decades. Its memory, just 69 kilobytes. And yet, year after year, it kept going. It captured volcanic eruptions on Io. It found the thick orange haze of Titan. It discovered Saturn's braided rings and Jupiter's magnetic fury. But long after the expected end, when its primary mission was complete, Voyager didn't die. It just kept moving. No maintenance, no upgrades, just a fragile metal body drifting farther than any human-made object in history. And as it moved beyond the planets, into the outer dark, it crossed into a region no probe had ever entered. That's when the real mission began. Discoveries that rewrote the solar system. Long before it reached the edge of the solar system, Voyager rewrote what we thought the solar system even was. Its first stop was Jupiter. Scientists expected a giant gas planet. What Voyager revealed was a raging colossus, a planet of crushing radiation, immense storms, and complex magnetic fields. But the real shock came from one of its moons. Io wasn't a dead rock. It was alive. Volcanoes erupted violently from its surface, ejecting molten material hundreds of kilometers into space. It was the first active volcanism ever seen beyond Earth. Then came Saturn. Voyager exposed the true structure of its iconic rings, braided, rippled, sculpted by tiny hidden moons. It found unexpected gaps, odd patterns, and dynamic interactions that made Saturn far stranger than anyone had predicted. But the most profound discovery was Titan. Enveloped in an orange atmospheric haze, Titan showed signs of organic chemistry. The thick nitrogen-rich atmosphere seemed hauntingly familiar, possibly resembling early Earth. Voyager couldn't penetrate the clouds, but what it hinted at changed how we viewed planetary evolution. Voyager 2, on its own trajectory, pressed deeper. In 1986, it reached Uranus, the only mission to ever fly by. There, it uncovered a planet rolling on its side, with a magnetic field wildly misaligned from its rotation. Then came Neptune in 1989, revealing supersonic winds and a dynamic atmosphere more violent than imagined. At Neptune's moon, Triton geysers of nitrogen erupted into space, freezing before they fell. Its surface appeared young, reshaped perhaps by internal forces. These weren't just curiosities, these were revelations. Voyager had revealed a solar system of dynamic, active worlds, moons with atmospheres, storms bigger than Earth, and magnetic fields that defied theory. The more it discovered, the more it reminded us. Space isn't empty. It's alive with the unexpected. But even the most distant planets are still part of home. When Voyager passed Neptune, there were no more worlds to visit, no more moons to image, only silence ahead. And in that silence, the solar system itself began to unravel. Into the void, the edge of everything. After the planets faded behind it, Voyager 1 entered a region no spacecraft had ever reached. the boundary between our solar system and everything beyond. But this edge wasn't a line. It was a battlefield. The solar system is wrapped in a vast invisible bubble known as the heliosphere, a shell carved by solar wind, the constant stream of charged particles erupting from the sun. For billions of kilometers, this wind pushes outward, forming a protective cocoon. But eventually, it hits resistance. The interstellar medium, the thin gas, dust, and radiation that fill the galaxy. Where these two forces collide is the heliopause, the true edge of our solar system. For years, scientists didn't know what to expect. Would Voyager crash through a wall? Would the transition be smooth? Theories were plentiful, but in 2012, the signals changed. Voyager 1's particle detector saw solar particles vanish, magnetic fields shifted, outside forces were pushing back harder, and then plasma density spiked. It had crossed the heliopause. Voyager 1 was the first human-made object in interstellar space. In 2018, Voyager 2 followed. But strangely, it didn't detect the same things. Voyager 1 had encountered dense pockets of interstellar plasma, almost like walls of invisible pressure. Voyager 2 found something different, a stream of stretched-out particles flowing in strange directions. Same boundary. Two different experiences. Even more unsettling was what both craft recorded next. The heliopause wasn't smooth, it was wrinkled. Giant magnetic folds, shaped by solar eruptions, stretched billions of kilometers across space. These weren't static. They moved, shifted. In some places, they seemed to follow the probes. Models failed, predictions broke. The solar system's edge, once imagined as serene, was chaotic, turbulent, loud. Voyager hadn't found peace in the outer dark. It had found noise, pressure, movement. The edge wasn't the end, it was just the beginning. The glitch that should have ended it all? In late 2023, decades after Voyager 1 had crossed into interstellar space, something went wrong. The signals it sent back were broken. Garbled fragments, disorganized bits of data that made no sense. Telemetry vanished. There was no readable information. It wasn't a normal malfunction. The spacecraft was still alive, still transmitting. But what it said was incomprehensible. At first, engineers thought it might be a temporary disruption. Perhaps cosmic rays had scrambled a packet in transit. But diagnostics revealed a deeper problem, a corrupted section in the flight data subsystem, a fragile memory bank responsible for organizing all data before transmission. A single chip, likely struck by radiation, had flipped a few critical bits. It wasn't just a glitch. It was a failure in the spacecraft's core memory, a part of the system no one had touched since the 1970s. There was no backup, no repair tools, and the engineers who had designed the system, most were retired or gone. Yet, at NASA's Jet Propulsion Laboratory, a handful of mission veterans and young engineers refused to give up. They poured through ancient documentation, dug up hardware schematics from 4 decades ago, and began rebuilding the system, line by line, byte by byte. The fix had to be sent 24 billion kilometers away. One way, it would take over 22 hours to arrive. And if they got it wrong, even by a single line, the spacecraft could go dark forever. In April 2024, they transmitted the patch. Then, they waited. The response came days later. The signal was clean. The data was whole. Voyager 1 had recovered, remotely reprogrammed from deep space, by a team that refused to let it die. It wasn't built to be fixed, but it was. Messages to the unknown. Long before Voyager left the solar system, before it passed Jupiter's storms or Saturn's rings, engineers attached a golden disc to its frame, a message not for us, but for them. It was called the Golden Record, a 12-inch copper phonograph coated in gold, sealed in an aluminum case, and bolted to the spacecraft's body. It carried greetings in 55 languages, the sound of a heartbeat, wind, thunder, and music from across cultures. Bach, Blind Willie Johnson, and a Navajo chant. There were diagrams of human anatomy, DNA, and Earth's location in the galaxy mapped using pulsars as signposts. The record was never expected to be found. The chances of another civilization intercepting a 70s-era spacecraft drifting through infinite space, were nearly zero. But that wasn't the point. It was Carl Sagan's vision, a gesture of cosmic humility, a declaration that somewhere, in the brief blink of time, a species existed that could not only observe the stars, but wanted to be known by them. Instructions etched into the disk explain how to play it, assuming a finder can read physics. Even the medium, gold, is a symbol, durable, timeless. It's not a broadcast, it's a whisper. And even if no one ever hears it, it still says what mattered most. Drifting into forever. Today, both Voyager spacecraft are still out there, silent, steady, moving farther from Earth with every second. Voyager 1 is now over 24 billion kilometers from home, the most distant human-made object in history. Voyager 2 trails close behind, each continuing their long journey into the void. Their instruments are slowly going dark. Power from their nuclear batteries fades year by year. To conserve energy, NASA has been shutting down systems one at a time. By the mid-2030s, the Voyagers will fall silent. No more plasma readings, no more magnetic field data, just cold metal drifting through space. But silence isn't the end. Even without power, the Voyagers will keep flying, untouched and unseen, for tens of thousands of years. Long after Earth has changed, long after the last signal fades, they will still carry their golden records, echoes of our existence, spinning through the dark like ancient relics. And yet, they still teach us. Every difference between their readings, temperature, density, pressure, tells us something new about the space between stars. Voyager 2's plasma instrument still captures valuable data. Voyager 1's magnetic sensor still detects faint waves of charged particles moving across the galaxy. Even now, 48 years after launch, they're rewriting what we thought we knew. They are no longer missions. They are monuments. They were never built to last, but they became eternal. Drifting through the dark beyond memory and maps, Voyager carries us still, not as a signal-seeking reply, but as quiet proof that we reached for the stars and left behind something that mattered.